I'm going to go over a few problems from the Math 3 Unit 5 Worksheet 1. Sampling and study methods. The instructions are to identify the type of sampling method used in each example below, then identify any bias in each method. So number 1, the manager of Save Mart wants to find the percent of shoppers who bring their own bags. He interviews every shopper entering the produce section. So this is what we'd call a convenience sample. It's a convenient sample because it's something that's convenient for that manager. He's able to just go in one particular location during one particular time. It's not going to take much time to do it, and whoever shows up in that section, he's going to ask this question, or maybe just observe and see, who brought their own bag. So this method does involve bias. It's not it's not a good sampling method, and to identify some kind of bias in this one, he wants to find the percent of shoppers who bring their own bags. And so what about the shoppers that are not going to go to the produce section? Not everybody that goes shopping is going to go there, so those people are not part of the sample. What about those that go shopping at a different time than the manager was there? So maybe the manager was there during the morning time. It doesn't say. And there's lots of people who are working during that time, and so those people that didn't go shopping at that particular time or on that particular day were not represented in the sample either. And so that's what we mean by a bias sample. A bias sample is a sample that doesn't represent the population the way it is. So I'm just going to put a couple of those things down. Convenience sampling, an example of bias in this method or in this situation would be not representing the shoppers who did not go to the produce section. Alright, number 2. A school principal gathers an alphabetical list of all the students in her school, or at her school. Then she selects every 15th student to take a survey about the cafeteria's lunch menu. Okay, so this is a random method in which there's a list of the whole population that the student obtains, and then there's a systematic way of selecting those students, so every 15th student is selected. So this is a systematic random sample. And when the sample is random, and it's random in the sense that everybody in the population is represented, and in this case it was, because she had an alphabetical list of all the students. If it was just some of the students, it wouldn't be good, but we had all the students, and there was a systematic way of selecting those that wasn't taken from her judgment, but more of a system that was out there. Then this kind of sampling gives you a good sample, an unbiased sample. And so we do not have to identify any types of bias here. Number 3, an online advertisement asks you to participate in a survey. The survey asks how much time you spend online each week. So here we have just this online advertisement that just goes out to whoever sees it. And then if you see that advertisement, you get to choose whether or not you want to participate. And so you get to select yourself. And so this is a self-selected sample, which we call a voluntary response sample. And this type of sampling always introduces bias, because usually the people that decide to respond to the samples are those that feel most strongly about the situation. So in this case, how much time do you spend online each week? It may be somebody that has some strong feelings of people that spend too much time online, or this one maybe it's not as emotionally driven, but there are a group of people out there that would not respond to these things, wouldn't have the time to do that. Maybe they're overly busy, maybe other factors are involved, and so this type of sampling is not going to represent the population in which it strives to represent. So an example of bias in this situation is that the sample would not represent those who typically wouldn't respond. Alright, now we're going to skip to number 8. 8 through 10 is a little different than 1 through 7. Here we're identifying the study method, not the sampling type, but the study method. And there are 3 types of study methods. It could be an observational study, it could be an experiment, or it could be a survey. So number 8, we have a school. Let's continue reading the instructions here. So we identify the study method described in each situation, and we're going to explain whether the sample statistics could be used to make a general conclusion about the population. Okay. So 8, a school psychologist sits in a school cafeteria and takes notes on the students' behavior while they eat lunch. Okay, so this school psychologist is just simply observing. An experiment is when you impose some kind of treatment, and the psychologist is not doing that. A survey is when you actually gather, like a questionnaire for the students. It doesn't indicate that that's happening either. So this is simply observing the students. So this is an observational study. So our study method is an observational study. Then we want to identify the sample statistics. So the sample that the school psychologist is using is um, those students who are in the cafeteria on that particular day eating lunch, and the statistics is the numbers or the data collected from these students, and we are told it has something to do with their behavior. We don't know exactly what kind of behavior, and so that's all we can write here. So our sample statistics are notes on student behavior. And then we're asked, can those notes on student behavior be generalized to the population? So it's not specific to what is the population here. It could be the whole school. It may be generalizing to everybody in the United States or in the world. So it's not specific in that sense. But let's say the school's our population. Could this psychologist generalize their findings to the whole school? Well, that really has to do with is their sample unbiased or is it biased? In this case, I'd say it's biased because we're just looking at one place, one time, and it doesn't represent the whole school because not everybody had an equal chance of being at that particular time and place. And so explain whether the sampling statistic could be used to make a general conclusion. So we could not use these results to generalize to the population. Because not everyone in the population was, let's say, was selected randomly. Or had the chance of being selected randomly. That would be a better way to say it. Number 9, a researcher places 50 houseplants of the same type and size in each of 2 identical soundproof rooms. Each plant receives the exact same amount of water and light. Classical music is played continuously in one room and no music is played in the other room. After 30 days, the researcher measures the growth of the plants. So the study here is an experiment. And what makes it an experiment is treatment was imposed. And the treatment is the classical music. So one set of plants got the classical music, the other set of plants didn't. The statistics gathered was the growth of the plants. So the sample statistic growth. And so if this particular researcher finds some results, so say this particular researcher finds that classical music did cause one set of plants to grow more than the other set that didn't have the classical music, could they generalize that to all plants out there? Again, no, because the same reason for number 8, we can't use these results to generalize to the population because not every plant or every seed or in that population had a chance of being selected randomly. And typically experiments are not, the purpose of an experiment is not to generalize to a population. The purpose of an experiment is typically to determine cause-effect. But we're asked to comment on that, so we could not generalize to the population of all plants because not all plants had a chance of being selected randomly. And then number 10, a company selects every 20th name from an alphabetical list of a company's employees. The employees selected are asked whether they are satisfied with the company's benefits package. Okay, so here we have a list of all the company's employees, which is our population. Not all of them are selected, just a sample of them are selected, but they're selected randomly, and that every 20th name is gathered. So this study method is a survey. The sample statistic is the information they gather, which is employee satisfaction. And in this case, we can generalize to the population of all company employees. Because all employees had an equal chance of being selected to the sample. Number 19, answer the following question. In the last election, a survey of randomly selected registered voters was conducted to determine which candidate was likely to win. 49% of respondents chose candidate A, and 45% chose candidate B, with 6% undecided. Based on the sampling results, can you make a general conclusion that is more likely that candidate A will win the election? Explain. Alright, so in this, candidate A had 45%, and oh, I'm sorry, I'm reading that wrong. Try that again. 49%. And 45% went with candidate B. We don't know if the method used was biased or not. If it was biased, then our results don't mean anything, and so we can't make a conclusion. Um, also, we don't know about the 6%. If those 6% go with candidate B, then you have more people going with candidate B. So we don't really have, and then also these are just statistics. You know, there's some error involved in statistics as well. So, you know, our sample may be 49%, but in reality it may be a little less than that, and our sample said 45% for candidate B, but in reality it may be a little more than that. And so we cannot make a general conclusion because of, I'd say, three things. One, the sample may be biased. Two, there may be sampling error. And you know, we may have a small sample size that we took this from, or maybe we don't know the sample size. And then third, we are not sure how the undecided group will vote.